Now that we're done with the power rule, what if the function that you are differentiating starts with a numerical coefficient? What differentiation rule will apply? So we have a differentiation rule which is called the constant multiple rule. So it states that if f of x is equal to k times h of x, where k is a constant, then the derivative of f of x is equal to k times the derivative of h of x. So basically, what you'll do is just copy the constant, get the derivative of the function, and then afterwards simplify it by multiplying them. Now let's apply the constant multiple rule in some examples. The first one, what if we are given g of x is equal to 2x raised to 6. So as you can see, we have here a constant and a function, which is specifically a power function. So what we'll do to find the derivative of g of x is just to copy 2. So parang dito, k lang siya. And then get the derivative of the function. So get the derivative of x raised to 6. So 2 times, so derivative of x raised to 6, recall natin sa power rule, we have drop the exponent, copy the base, subtract 1 from the exponent, and then simplify. So we will have the derivative of g of x is equal to 2 times 6x raised to 5, which when we simplify further will give us the derivative of g of x is equal to 12x raised to 5. And that will be our final answer. Now let's try another example. What if we have h of x equals negative square root of 7 x. So we have here a constant and a function. So that will be h prime of x, or the derivative of h of x is equal to, just copy the constant, so negative square root of 7, then get the derivative of x. And as you may have remembered, the derivative of x from our previous discussion is just equal to 1. Then simplifying this, we will get the derivative of h of x is equal to negative square root of 7. And that will be our final answer. Now let's proceed to another example. We have j of x is equal to 5 over x cubed. And before we proceed with that, let's recall. When we say 1 over x raised to a, this is just the same as x raised to negative a. That is, we get the reciprocal. So that means j of x equals 5 over x cubed is just the same as j of x equals 5 times x raised to negative 3, which means that we can still apply the constant multiple rule. So that is, the derivative of j of x is equal to, copy the constant which is 5, and then get the derivative of the function. So this is a power function, so we can apply the power rule. So drop the exponent, copy the base, subtract 1 from the exponent. And then from there, we have to simplify. So the derivative of j of x is equal to 5 times negative 3 x raised to negative 4. But then again, we can still simplify this further, which will give us the derivative of j of x is equal to negative 15 x raised to negative 4. How did I get the negative 15? Simply multiplying 5 and negative 3. So now, let's try another example again. So, if we are given p of x is equal to 1/3 of the cube root of x squared. So, we have discussed this before. Let's recall that the nth root of a raised to b is just equal to a raised to b over n, which means that we can rewrite this into 1/3 times x raised to 2/3. So which means that we can still apply the constant multiple rule. So that is, the derivative of p of x is equal to 1/3 times the derivative of x raised to 2/3. So drop the exponent, copy the base, subtract 1 from the exponent. So we will have p of x, or the derivative of p of x, is equal to 1/3 times 2/3 x raised to, so subtracting 2/3 and 1 will give us negative 1/3. So this is, when we simplify, always remember to simplify if it's possible. So the derivative of p of x is equal to 1/3 times 2/3 is equal to 2/9 times x raised to negative 1/3. And that will be our final answer. If you have any questions, please feel free to send me a message via Neo, and please click on the next video for the discussion of the next differentiation rule and its examples.